This is going to be a review of the periodic table. We started looking at patterns and information in the table in the last unit, and in this chapter we're going to continue with those studies. So let's take a look. Here's a colored periodic table similar to the one that's in your note-taking guide. Remember that the table is set up so that elements in the same group or family, which are columns, have similar properties. The periods of the periodic table are the rows that move from left to right or horizontally. Now the first periodic table was created by Mendeleev, and he organized the table by atomic mass. But that didn't work out for every element that was discovered later. So Henry Moseley actually created the table that you see on this slide, the modern periodic table. He organized the table by atomic number. The lanthanides and the actinides were pulled down to the bottom of the table as they were discovered by a scientist named Glenn Seaborg. And we'll talk about him later. What I want you to do at this point is to review the parts of the periodic table. On this slide you can see on the left side hydrogen is white. It's on the left where all the metals are located, but hydrogen's not a metal. It's actually a nonmetal. So always remember it's a little bit out of place. The green column or group number 1 on the left side are the alkali metals. These are very reactive metals and they have one valence electron. Next to the alkali metals is a yellow column named the alkaline earth metals. Group 2 elements have 2 valence electrons in their outer shell, and these metals are also very reactive. Now as you go all the way to the right side of the periodic table, there's a dark yellow column, group 18. Those are the noble gases. All the noble gases have 8 valence electrons. They have a full outer shell, or an octet. The word octet is used because they have 8 valence electrons. Now the thing that's special about noble gases is that they don't make any compounds, very rarely. To the left of the noble gases in group 17, it's kind of a light orange column there. Those are called the halogens. Halogens are in group 17. They have 7 valence electrons in their outer shell. Now these are nonmetals and they are reactive, so you will see compounds made with these later on. As you look at the separation on the staircase between metals and nonmetals, remember that staircase starts underneath boron and works its way down and to the right. The metalloid elements are light blue on top of the staircase and on the sort of below the staircase. All those other dark blue elements are metals, but they don't have special names. The last group that I need to give you the special name for are the orange ones in the center part of the periodic table. Those are called the transition metals or the transition elements. They generally will have 1, 2, or 3 valence electrons in their outer shell. Silver is one notable exception. Silver will always have a charge of +1. It will give away 1 valence electron. And finally, the part of the table that Glenn Seaborg organized, the lanthanides and the actinides are those pink colored elements, the 2 rows at the very bottom. Those fit into the main part of the table where you see those stars beside barium and radium. If you look at those and consider how the lanthanides and the actinides are in about the same location as the transition elements, you're going to see that they too will have 1, 2, or 3 valence electrons. Usually you're going to go with 2, and I'll tell you how to notice the difference and to know which one to use as we go through this chapter. Alright, so make sure that you review the number of valence electrons. Group 1 has 1. Group 2 has 2, Group 13 has 3, Group 14 has 4, Group 15, the nitrogen group, has 5 valence electrons, Group 16 has 6, 17 has 7, and then the noble gases, Group 18, have that full octet or full valence shell, which is 8 valence electrons. Bring that with you tomorrow and we'll add to it as we go. Thanks!